In 1964, the Austin 1800 arrived with an ordinary 85 horsepower engine and a bizarre squat body that earned it the nickname the Landcrab. Yet, it shocked journalists by gliding over rough European roads with eerie Rolls-Royce level stability. Beneath its controversial skin lay a radical wide-track packaging triumph and a groundbreaking fluid interconnected suspension that completely out-engineered the global automotive establishment. To understand why the Austin 1800 drove like nothing else on Earth, one must understand its creator, Sir Alec Issigonis. Flushed with the historic runaway success of the mini and the medium-sized Austin 1100, Issigonis was given a mandate to apply his radical design philosophy to a large, upscale executive vehicle. Code-named ADO-17, this new project was designed from the inside out. Issigonis possessed a borderline obsession with maximizing interior passenger space while strictly minimizing the car's external footprint. His engineering strategy was uncompromising. He took the wheels and pushed them outward to the absolute four corners of the vehicle. By completely eliminating traditional front and rear body overhangs, he freed up a colossal 106-inch wheelbase. To maximize passenger legroom, Issigonis took the 1.8-liter B-Series engine and mounted it transversely sideways across the engine bay, mating it to a transmission that sat directly underneath the oil sump. The result was a packaging masterpiece that utterly defied the laws of interior space. Externally, the Austin 1800 was actually 17 inches shorter than a traditional mid-sized Austin Cambridge family sedan. Yet, step inside, and the cabin dimensions, legroom, and shoulder room were identical to a massive 3-liter luxury executive vehicle. It was a wide-track, low-slung platform that gave the vehicle an incredibly low center of gravity and a footprints-to-body ratio that made it inherently stable before the suspension components were even bolted on. But a long wheelbase and a wide track mean nothing if the car's structural chassis flexes under load. This is where the engineering team at Longbridge pulled off their second major triumph. They engineered one of the stiffest, most structurally indestructible passenger body shells in automotive history. Issigonis knew that to achieve a true luxury ride quality, the suspension components needed an absolutely rigid foundation to work against. If the body twisted or flexed when hitting a bump, it would absorb kinetic energy incorrectly, ruining the car's ride harmonics. Therefore, the engineers built the Austin 1800 like a military bunker. The central monocoque structure featured massive, deeply boxed sills, a heavy-duty reinforced bulkhead, and a structural stiffness that resembled a submarine hull rather than a thin-gauge 1960s family car. When the engineering team completed their torsional rigidity tests, the numbers shocked the industry. The Austin 1800 chassis registered a staggering rating of over 13,000 foot-pounds per degree of twist. This was more than double, and in some cases triple, the structural stiffness of its contemporary rivals from Ford, Vauxhall, and Roots. It was a structure so over-engineered, heavy, and bulletproof that it would later allow the car to become a dominant, unkillable legend in brutal endurance rallies like the London-Sydney Marathon. This absolute rigidity meant that road imperfections were isolated entirely within the suspension units, completely shielding the passengers inside. With a wide, ultra-rigid chassis established, Issigonis deployed the crown jewel of the Austin 1800's design, hydrolastic suspension. Designed in partnership with the brilliant inventor, Dr. Alex Moulton, this system completely threw out traditional steel coil springs and telescopic shock absorbers. Instead, it relied on a highly sophisticated network of fluid displacement and rubber springs. At each corner of the vehicle sat a sealed displacer unit containing a heavy-duty tapered rubber spring and a fluid chamber. The magic, however, was in the interconnection. The front displacer unit on the left side of the car was connected directly to the rear left displacer via a small bore hydraulic pipe. The right side featured an identical, mirroring layout. The entire system was hermetically sealed and pressurized using a highly specific hydrofluid recipe, a mixture of 49% water, 49% alcohol to prevent freezing, and 2% corrosion inhibitors with a signature green dye. The operational mechanics of this system were pure engineering genius. When the front wheel hit a severe pothole or a bump, the wheel moved upward, compressing the front displacer diaphragm. This forced the pressurized hydrofluid down the small bore pipe toward the rear unit. As the fluid entered the rear chamber, it gently pushed the rear wheel downward, lifting the back of the car before it even reached the bump. In a traditional car with steel springs, hitting a bump causes a choppy, nodding motion, known as pitching, where the nose rises and the tail drops. The Austin 1800's interconnected fluid network completely neutralized this. By dynamically transferring fluid front to back, the car kept its body completely flat and level, gliding across waves in the asphalt like a ship on a calm harbor. Furthermore, the system possessed an inherent, speed-sensitive, damping characteristic. At slow speeds, the fluid flowed easily through the pipe, providing an incredibly soft, cushioned, low-speed ride. But as the vehicle sped up on the highway, the restriction of fluid traveling through the narrow piping naturally increased. The suspension automatically stiffened up at high speeds, providing rock-solid stability and razor-sharp handling, all without a single piece of complex electronics. While the chassis and suspension belonged in the aerospace industry, the powertrain was a lesson in old-school British reliability. Tasked with moving this incredibly stiff, heavy, 1,200-kilogram machine was the legendary 1798cc BMCB series engine, the exact same power plant found in the classic MGB sports car. Generating a humble 85 brake horsepower and 90 foot-pounds of torque, this overhead valve engine was never designed for high revving performance or land speed records. It featured a rugged cast-iron cylinder block, a simple single carburetor setup, and a focus on low-end torque delivery. Because it lacked high-end horsepower, the Austin 1800 was never going to win a straight-line drag race against the high-revving sports sedans coming out of Germany or Italy. It took a leisurely 17 seconds to reach 60 miles per hour, topping out at just around 90. But speed wasn't the goal. The brilliance of pairing this low-stressed 85-horsepower engine with the Landcrab's sophisticated chassis was efficiency of momentum. Because the front-wheel drive layout, wide track, and hydrolastic suspension gave the car immense cornering grip and total resistance to body roll, drivers didn't need to brake for bends. You could pin the throttle, let the B-Series engine sit in its torquey sweet spot, and maintain a high average speed regardless of whether the road was straight, twisting, wet, or broken. It was a relentless, unshakable cruiser that delivered maximum comfort across long, grueling European journeys. Ultimately, the Austin 1800 stands as one of the most fascinating tragedies in British automotive history. Winning the prestigious European Car of the Year award in 1965, it outthought the world in cabin packaging, outbuilt everyone in structural durability, and delivered a magic carpet ride quality that genuinely rivaled luxury cars costing 3 times its price. But on the showroom floor, engineering logic clashed with consumer psychology. The public found its wide, squat, overhang-free dimensions too radical, its heavy, unassisted steering was difficult to park, and a clueless boardroom failed to market its hidden mechanical virtues. Buyers seeking prestige shied away from the ordinary Austin badge, while families found its advanced technology intimidating. The Landcrab remains an enduring monument to what happens when brilliant design is suffocated by a lack of corporate vision. It was a masterpiece trapped inside a polarizing skin, proving that underdog British engineers could turn 85 humble horsepower into a mechanical marvel that shocked the elite automotive world.